Hello friends and welcome back. Welcome to the last session of Industrial IoT. Okay, let's start with the main topic here, how the IoT and IIoT are differentiated. The things which are common, which are mentioned at the center of it, if you are comparing IoT and IIoT. Data management, connectivity, okay, data management, connectivity, data security, secure clouds, these things are common in it. But if you consider basic IoT, so basic IoT is for household usage or for the commercial sectors, we'll be making use of it. So these are the common application that IoT will have. But IIoT will have the industrial sector, so industrial applications in almost all kind of industries, including computer IT industries, automobile industries, manufacturing industries, or aviation industries, oil, gas, like all everywhere we are going to make use of the IoT. That's the main difference that we can achieve between IoT and IIoT. Let's focus on more. So IoT it connects machine and devices in such industries like oil and gas, utilities, and manufacturing. IIoT will have system failures and downtime in IIoT deployments can result in high risk situations or even life threatening situations also. That's the main part. But in basic IoT, it's not the case. It is secondary part, means when you implement and we don't have any high risk situations in basic IoT. But IIoT systems should be perfect. Why? Because industries are working on the high risk situations, even life threatening situations also. That's why system failures must be almost equal to 0%. IoT applications are also concerned with improved efficiency and improved health or safety versus the user-centric nature of the IoT applications. So basically, IoT applications are centralized towards the industrial things only, where IoT is user-centric. So user is there, and that user is handling the systems, and based on that, we are going to implement or make use of the particular IoT system that we have achieved from there. These are the common differences that IoT and IIoT is having. Their architecture may be almost common, just like the brain of the different animals. They are almost the brain is common, but their architecture is somewhat different everywhere, and their operations are also somewhat different. But overall, in general, in common, architecture of brain is same for almost all kind of animals, like that. Now, common applications where we can make use of the IIoT in industries. Okay, so common industrial applications in manufacturing sectors, factory or manufacturing sectors, we can implement the IIoT easily. Smart grid, yes, electricity applications, that is smart power and utility applications, smart communications. So in communication industries also, we are having the huge applications of IIoT where it can be implemented easily. Smart city, one of the now trends in it. So when city corporations are making the things online, they are making the things automated. Just like take an example of traffic signal. A city corporation wants to automate the traffic signals based on the traffic flow. Can I do that? It's not yet implemented in any of the cities in India, but it can be done. We can make these traffic signals green and red as per the traffic flow on the roads. Okay, just an example I mentioned. So in this way, we can make use of these IoT applications so much easily. Okay, even if you consider toll plaza by the road transport departments, what they have made FASTag. Now FASTag is also one of the application of IoT. So this is how IoT applications can be implemented in the smart cities. Even smart cars, just take an example of it. Some companies have manufactured many devices, like you need to check the pressure, air pressure in the wheels of the car. So there are some devices available by which you can connect with your wheel, you can talk with the wheel, and you can find its properties easily on a mobile also. So just an example I mentioned, smart car. Even some camera that they are put at the back of the car, and when another car is coming close to your car, so you'll get an alarm, you get a siren. We can get a system by which you can just get informed by this that the car is coming closer to you. That's okay. This is what the applications of the IoT in smart car or robotics. Almost many applications are now getting done in the industries by the robotic mechanisms, and to control that robot, to make this robot automated, we can make use of the IoT applications. So these are the commonly IoT systems where the IoT can be implemented easily. not easily basically. It can be implemented and we can achieve the benefits of it. We can make it automated systems through the IIoT. Now, what are the vendors? So, see, there are the common vendors I just mentioned who are working on IoT system design, just like Ability by ABB, sorry. A power and robotics company is there. IoT system by Cisco. You might have heard about this name as a networking company. Filled by the Fanuc, supplier of industry automation equipments. Predicts by GE Digital, energy management company, or Honeywell. So, it's a software industry company also providing this connected performance services in IoT. Okay, or KUKA. Okay, yes, that's a robot actually, KUKA. So manufacturing industrial robot created in partnership with Infosys, an IT consulting firm from India. Even Wonderware by Schneider Electric, energy management company, and the MindSphere by Siemens, an industry manufacturing company. These are the top companies: Cisco, or IBM, ABB, GE Digital, Honeywell, or the KUKA, or Schneider Electric, or Siemens. These companies are working in the IoT product development. Okay, if you just go to Google and just type it IoT vendors in India, so you'll get lots of companies there which are working on the IoT. Even we also, in Metascalologies, we also work on the IoT based projects, and not yet product development, but project development, the service providers on IoT. Lot many companies are there which are providing these services here in India also. What is the future that IoT, industrial IoT will have? So Bain and Company predicted the industrial IoT applications will generate more than $300 billion by 2020, double that of the consumer in IoT segment. Okay, that's what we have, having $150 million only. IoT and IIoT. That's what at the start of the session I told. 2/3 share of IoT is there in IIoT only, and 1/3 will be there in the basic IoT. Similarly, IDC Research reported the top 3 industries investing in IIoT in 2018 are manufacturing. Okay, top 3 industries for manufacturing only, that is $189 billion, with a focus on asset management, transportations with 85 billion, with focus on freight monitoring and fleet management and utilities with 73 billion, with the focus on the smart grids and consumer IoT spending with reach $62 billion. Okay, so here manufacturing companies are on the top, which are basically implementing the IIoT applications so much effectively. More optimistically, Accenture, okay, might be knowing, it's a multinational company. They are having their branches in India also. Expects IIoT to add $14.2 trillion to the economy in the same time period, growing at 7.3% compound annual rate through 2020. This is what the predictions are. $14.2 trillion in the economy. Okay, remember that's what the expectations from the industrial IoT. So when we are going to boost the economy, so it will be considered that IoT applications so much they should be effectively implemented in the industries, so that we can achieve the compartment to the economy so much benefit. Okay, now basically, see, IIoT, we talked about the IIoT, but there is a consortium, okay, which maintaining the communication between the or among the companies who are working on IIoT basically. So this is what IIC is. The Industrial Internet Consortium. It was founded in the March 2014 to bring together the organizations and the technologies necessary to accelerate the growth of the industrial internet by identifying, assembling, testing, and promoting the best practices in the IIoT sector basically. So they are working from last 6 years for organizations who are working on the IIoT. Members work collaboratively to speed the commercial use of the advanced technologies. Okay, commercial use of the advanced technologies, how to implement that, they work collaboratively over there. Membership includes small and large technology innovators, vertical market leaders, researchers, universities, and government organizations. Many companies we are working on the IoT sectors, not only basic companies, all kind of innovative companies, research companies, vertical market leaders, researchers, universities also, government organizations also, they are now the part of II Consortium, Industrial Internet Consortium. You can just check it out their web. On that particular website, all information, their activities, and the information about the IIoT can also be achieved. You can just check it out, this particular website, iiconsortium.org. Now let's focus on the future now. So we talked about IIoT, but now what can be the future? factory of the future. Check it out. So this is just an example I just taken by from the CB Insights, how the factory of the future can be built. Okay, see many things which are mentioned over here. Just check it out. They are the unmanned trucks. Unmanned trucks. Make sure unmanned trucks. Now computer vision. Here we are making use of this camera to capture the product's goods. With the help of image processing, we find the quality of this manufactured goods. Okay, yeah. Then blockchain. You might have heard about the blockchain. So blockchain is a novel technology today used for the cryptographies. Enterprise resource planning and supply chain management. Here we can make use of it, blockchain, and with the help of that, this generation of security or resource planning, ERP, can also be done. Here we come with the predictive machine analytics. Now, whatever the machines which are used, what are the performance of this? How performance is growing, performance is decreasing, that we can easily find by using predictive machine analytics. There is a technology called machine learning. It's part of artificial intelligence. With the help of that, this prediction can be easily done. Or even you might have heard about AR and VR, augmented reality. Okay, so industrial augmented reality, that can also be used over here. Even virtual reality also, you just can without directly operating the machine, virtually we can create a simulation of it. Okay, like that we can make. Here we are using IoT sensors for supply chain management. We just find how much things are remaining and what's the need of manufacturing in future. That we can find by using IoT sensors. Then modular equipments, common modular equipments by which a computer can read, computer can check, okay, these are the machines in which this particular way the product should be manufactured. So that will be taken. These are the modular equipment which will be used by the computer systems. And coming all these things together, one more thing is there called as cobots, okay, collaborative robots, that also we can use over here. Okay, they are also controlled by the IoT system. So this is how the factory of the future can be. Now you just look at the factory, only 2 employees are there in this particular picture. Okay, disadvantage is that we are going to reduce the number of employees, but remember, IoT also create the opportunities for new employment. Remember, IoT also having, so we need to grab that particular skills to be the part of IIoT. So skills are changing, employability is constant, it's also not increasing much, but it's almost at the continual level is there. The revenue market. So what revenues are expected? So from industrial ARC analysis and expert insights, I've taken this one. Industrial Internet of Things market revenue from 2015 to 2021 is growing continuously in the $1 million. So obviously this is a novel technology which is achieving many advantages in the industry. So obviously it's growing fastly, and it's a need of industry that they need to implement the IoT systems within their industries there. Okay, so that's what the achievement that we can take out of it. And what are the challenges? Most of the challenges are there. I just taken the common challenges here. The main challenge is security, IT security issues, which are greatly aggravated by the inherent need to open up those previously closed production jobs. Okay, security issues. Then we may have the reliability and stability also needed for critical machine-to-machine communication, including very short and stable latency times. Or need to protect industrial know-how. Okay, every industry contains its own area or own process of manufacturing. Okay, so we need to protect that know-hows. Lack of adequate skill set expedite the march toward the fourth industrial revolution. So building this system, handling these systems needs the manpower. Okay, so that skill set is inadequate, so that should be improved. Loss of many jobs to automate processes. This so already I told about. Loss of many jobs to automate processes and IT controlled processes, especially for lower educated parts of the society. Lower educated part of the society, okay, they will be affected by this particular system, okay, because they are not having qualification, and they will work as a worker. If the machine is doing the task of worker, so these common workers will be jobless. Unclear legal issues and data security. So cyber security laws should be they are not yet so much strong, so much perfect, so that should be changed, or that should be affected also. Lack of regulation standard form of certification. So some companies are, I showed about this IIC. IIC is working on that regulation standard form of certifications, but these things are changing company to company. These things are changing country to country also, and even policies of the industry also, they are different. So this regulatory bodies, standardization and certification, okay, this is still lagging. It will take some years to make it standardized, then only this process can be perfectly done. And the last one is insufficient qualification of employees. So employees are not yet qualified to handle these IoT systems, to create the IoT systems. Companies are now taking initiatives to train their employees, or they're already trained employees, like they are already having qualification of engineering or any computer applications, but they are not knowing the IoT systems. They are not knowing how to create it. They are not knowing how to handle it. That's why these qualifications of complete detailed analysis, detailed use of the IoT is still not there. Companies are working individually on that, and even IIS is also working on that to improve the qualification of the employees on the IoT systems. Okay, so that's it. That's from my point of view, how IoT and industrial IoT are actually differentiated, how the impact of them, how they're exactly been put, and what we can achieve, what we can say, what we have to learn, what we have to make for, what we have to use, what we need in future. So that things what we have discussed in all the sessions, and my summary is there on the screen. Just check it out. Internet of Things is only a tip of an iceberg. So just check it out. What we have seen, it is above the sea level. What level? And what we are going to use, what we are going to learn in future, it is below the sea level. Okay, tip of an iceberg. And many things that you have to learn by yourself. Maybe in upcoming sessions we'll be learning many things. We just have to practice it. You have to make sure that you are knowing the architecture, you are knowing the systems, how it's perfectly built, how it is perfectly implemented. With practical point of view I'm talking about. Many companies are there, just visit that companies which are working, which are already deployed the IoT applications within them. Maybe IT companies also deployed, many manufacturing companies also, automobile companies also. Everywhere that IoT systems are deployed, now everyone has deployed. Remember that it's not like all they are working on traditional systems. Everywhere is deployed. Just look at that, make a case study. We just search on some videos on YouTube which are showing the IoT and IIoT applications also, by which we can get a clear idea how the things can be effectively implemented. Still there are too much scope for improvement present possible. If you want to work on these projects, if you want to work on some kind of the systems which work on IoT, just again look at that particular system which are already implemented, so that your ideas can be easily added inside it. Okay, so you can learn the IoT, and this is just a beginning for learning the things. Many things are available in future. Just you can go through that, and if you are having any doubts or any questions regarding the same, you just can contact me on the given web resources, or the given mail IDs, or on the given social networking links also. Thank you. Thanks a lot.